artificial intelligence algorithm or meta-heuristic algorithm implementation. This method of implementation, FPGA implementation, is very, very good. Then FPGA implementation is a special method of implementation that is very proper for some special cases, like that I told you, image processing, special signal processing, and neural network implementation and other things. And which kind of language is proper for, programming or implementation on FPGA? HDL, Hardware Description Language, VHDL, or Verilog. Then now you know the main application of VHDL. After modeling and testing a digital system, the other application of VHDL is FPGA implementation. In the other slide, we can speak about different levels of design. Because as I told you, HDL is a hardware description language. We have different levels of description, different levels of speaking about a system. Each designer can work in any level of system design, and these levels can map to each other really. We have system level, a systematic point of view. Algorithmic level, we um, we really synthesize the system into some main algorithm. RT level, it means register transfer level. It means that we must synthesize the system into some main registers, and the um, um, changing the data between these registers is really um, what a thing that um, happened in this system. Another level is logic level, and by this method of or this level of uh, system design, we change or we map the system into all logic functions. And physical level can be, we can state at this level by changing the logic functions or logic processing elements into their physical implementation, like transistors and something like this. We have a Y chart here. Y chart um, shows us three main domains of implementation. Physical domain, we speak physical domain, what we have from a system, for example, a chip, a board, an IC or something like this. A structural domain, it means that we have the architecture, the main structure or the main schematic of a system. And behavioral domain, this domain we speak about, we describe the main application or the main functionality of the system. And also we have different levels of design: system level, algorithm level, register transfer level, logic level, and circuit level. For example, in system level, we have three domains. In physical domain, we have the board, the main board or the main chip of the system in system level. In a structural domain, we have the main parts of the system, CPU, memory, and some other blocks like this. In behavioral domain, we have a system specification, some main statements about the system description or specification. In algorithmic level, in physical domain, we have some blocks or some main chips on the system, on the board. But in a structural domain, we have we focus on the system. We have processor, some other subsystems like memory, like some main ICs and their connections and something like that. And in behavioral domain for algorithmic level, we have the main algorithm or the main algorithms of the system. In register transfer level for physical domain, we have some macro cells, the main cells in the system and their connections. In a structural domain, we have some ALU or arithmetic logic unit and some registers, some multiplexers, maybe some decoders and something like that. And in behavioral domain, we have register transfer specifications, something like a code or something like a special code that speak to us about the main register transfer specifications. For example, changing data from one register to another register and its condition. In logic level, for physical domain, we have some subcells or some standard cells. In a structural domain, we have gates, flip-flops, we have the main uh, circuit and their building blocks really. And for behavioral domain, we have some Boolean functions or Boolean equations that describe the main working of the system. And the last one is circuit level. In circuit level, for a structural domain, we have transistors, really the main building block that shape our circuits, really, that make our circuit. Transistor make our circuit. For physical domain, we have some polygon groups or rectangles, really the main thing that really is related to the transistor. And in behavioral domain, we have some differential equations or some Boolean algebra equations and other things like that. And we can map each domain to another. We can go from one domain to another. For example, we can start by a behavioral domain. It is a general or a top view. The other domain is structural. And the last one is physical. We can start by behavioral domain. If we go from behavioral domain to a structural domain, really we have a kind of synthesis. We reach to the structure of the system from behavioral specifications. It is really a synthesis. We reach to the circuit. And if we change this domain from a structural domain to physical domain, we really generate the circuit. We call it generation. Then we have synthesis and then generation. If we go back, for example, from physical domain to structural domain, we call it extraction. Extraction, it means that we see the board, we see the ICs, we see the connections, and we notice the main structure of the system. And by analyzing this structure, we can go to behavioral domain. Then we go back from structural domain to behavioral domain as analysis. If we change the structure